Welcome to the Jack Westin MCAT podcast with your hosts, Michael Maleka
and Molly Hudash. Hello, everyone, and welcome back to another episode of our Jack Westin MCAT podcast with your hosts, Mike and Molly. Mike, it's lovely to be back with you again. And today we are talking about something that most people think is not lovely. In fact, about as opposite to lovely as it gets in many people's eyes. What are we talking about?
We are talking OChem today, and I already know somebody just heard that, and they're just like, "I'm shut off the podcast. This is I won't do anything." I mean, it's gonna be a little bit shocking, as the title will probably be OChem related, so you shouldn't be surprised when I said it.
Yeah, you signed up for this.
You signed up for this. But no, 100% agree, Molly. Like, I'm just gonna agree. Pleasure to be here talking with you. But also, so many students that we work with, like OChem, when they see it on a passage, when they hear about the concept, it's kind of like we shrivel up because a lot of us are scarred from like undergrad OChem, or even maybe even high school if we did a little bit of high school OChem, where it was such a struggle. OChem's just one of those classes where you either like it or you despise it with a passion, and most people fall under that second group. But I think I wanted to make it very, very clear, like right here, right now, for today and for the MCAT. Orgo on the MCAT is nothing compared to Orgo in undergrad. It's not the same at all. Orgo in undergrad, you've got to memorize a whole bunch of really specific reactions. There's so many different types that you have to remember. They're all open answer. You don't have, it's not a lot of times multiple choice, arrow pushing, all those things, where a lot of that stuff is what scarred us about OChem in undergrad. But on the MCAT, you don't need to do, like, you need to do a fraction of that. Not to say that OChem is not on the MCAT. Of course it's on the MCAT. We all know that. But compared to undergrad, it's like just scratching the surface. And even if it is on the MCAT, it's not even that big of a part of the kind of questions that you're going to see. Like we talked about last episode in terms of mastering CP passages, Chem Phys passages. If you haven't checked out that episode, go check it out. We kind of like really broke down the Chem Phys section and how to tackle passages using our strategy for the Chem Phys section. I want to reiterate, Orgo makes about 10 to 15% of all the questions that you get. I think the actual percentage is 15%, right?
Yeah.
Yeah, 15%.
It's like 10-ish questions, 10 to 12 questions out of 230.
Right.
So it's really not that.
It's really a small part of the Chem Phys section. Yet when we ask like students like, "Oh, what are you most dreading in Chem Phys?" They're like, "Orgo." When in reality, it's like a small sliver. And a lot of the times we don't even realize, and like this kind of came up in our conversation before, Molly, like what actually falls under Orgo, right? A lot of times when students think of Orgo, they just think of like, oh, nucleophiles and electrophiles, which we'll talk about in a little bit, but there's actually a few different things that fall under Orgo. So it's not like you have 10 to 15 questions on nucleophile electrophile reaction mechanism. In reality, you're probably gonna have maybe 3 to 5, possibly, if that. And so we're gonna be really breaking down like Orgo, but again, really want a quick reality check. It's not a huge part of this exam.
Yes. And again, like you said, it's not what you would expect coming from undergrad, right? Again, you're not going to see giant syntheses. You're not going to get a product and a reactant and say, expand the full 10-step reaction that must have been done to get here and list all your reagents. Like, I think OChem, one of the reasons why it's so difficult for so many students is, for most of us, it's the first course that really stops us in our tracks and forces you to acknowledge your tendency to memorize, right? I think undergrad bio, even, I think physics kind of does this too, but like bio, gen chem, biochem, and then all of our other subjects, I think for the most part, you can get by with memorization, especially at lower levels of learning. I think we can kind of, do our little cycle of take notes during class and then all-nighter in the library and do well on the exam, etc. But OChem is so deeply ingrained in your understanding. There's not really a memorization component, or it's hard. It's very difficult to memorize because so much of it is synthesis from your brain. But again, for the MCAT, it's very different from what we would expect based on our experience in undergrad. And I'll tell you right now, since this episode is about OChem, I was terrified of OChem in undergrad. I had different professors I was on the quarter system, all 3 quarters, and none of them I felt like were really that invested. I had one good professor which was right at the beginning, but then it just completely fell off the handle, right? So I was really scared about this. But like you mentioned, I think a lot of students are the most scared of all the reaction mechanisms and the arrow pushing, but really a huge percentage of OChem is actually just functional groups. Like, can you recognize the functional groups that are on molecules? Separation techniques and, or I guess, certain analytic techniques are also in OChem and make up a good chunk of those questions. And then for the most part, with these reactions, it's not that you need to memorize all of these arrow pushing mechanisms. And if you see these products and reactants, it's this type of reaction. I just need to regurgitate it from my memory. Most of the rest of OChem comes from, can I figure out what kind of even functional groups I have or reagents I have, and can I just imagine how I could go from this to this? It's not a like, you're not expected to memorize or know all of these reactions. It's basically, can I do a quick assessment of what I have and what I'm making? And can I just start to put together what type of reaction this might be? I don't need to know all the steps. I don't need to know all the details. I just need to be able to predict what could be going on. And this is the best part, pick between 4 answer choices about what is going
Amazing.
on. I don't need to be able to write a paragraph or be able to draw all the intermediates or do any of this. I'm going to get 4 answer choices. One of them applies to the situation. I just have to figure out which of the 4 it is, right? So
Right.
it's completely different. Again, we're going to talk about the general steps of how to approach OChem on the MCAT and kind of the passages types that you'll see, how it'll show up. We'll also touch on high yield topics, but I want to be super intentional here at the start of our episode that this is not necessarily a content episode. We're not going to go through everything, all the nitty gritty that you need to know for OChem, just because it would take kind of a long
You would
time.
be here. We would be here for 8 hours if we were
Yeah.
talking about all
And
the nitty gritty of every single
mhm,
like okay nucleophile, all the spectroscopy techniques, all the different functional groups, all like SN1,
yeah,
SN2 nuances, like all of these things would take so long to do in a
yeah,
single episode.
yeah. And it's
Mhm.
kind of counterintuitive because we're kind of trying to communicate that it's less about the nitty gritty, especially given how small of a percentage this is of your test. Not to say that you won't see OChem, you will, right? You're going to see 10 to 12 questions, but we more so want to give you the tools and expectations of how to approach OChem, right? What material is most likely to show up in those 10 to 12 questions out of the 230? And again, just reinforce the knowledge that this should not be a subject that you spend two months out of your 4 MCAT months studying. I say that because I tried to do that. I
You
thought
did
I was
that,
going to
yeah.
have to do that.
Mhm.
Study for 4 or 5 months. OChem is 2. That would have been a
Absolutely not.
nightmare.
Yeah.
Absolute nightmare. I would have
Mhm.
never achieved the score that I did. That would have not
Mhm.
helped me very much. So
Mhm.
I feel like we've set the stage. We know what we're going to get into. Where should we start? Maybe
I
start with what is high yield within
Yeah,
OChem.
like what are the
So,
topics? And we're gonna like touch on every one of these topics. We're not gonna go super in depth, but if you hear any one of these topics and you're like Mike, Molly, you're not going into it right now, but you're like, I want to hear you go super in depth on this topic, let us know in the comments. Let us know
mhm.
like, hey, when we talk about this first group, okay, we're gonna talk about stereochemistry first.
Yeah.
If you're like really want us to go into the difference like isomers and all those different types, let us know in the comments. We hear you and we can add that. But today we're just gonna be covering the overarching high yield topics,
Yeah.
which, like I introduced, the first high yield topic you should know for Orgo is stereochemistry. So stereochemistry is this idea of like understanding different things like chiral centers, like what a chiral center is, which is just a central atom with 4 different substituents. A lot of times that chiral center is going to be a carbon for the MCAT. So that's usually it's going to be a
Hmm.
carbon. Even though it's funny, Molly and I think we talked about this was like a few months ago. We were like, it doesn't in reality have to actually be a
Yeah.
carbon, but
Hmm.
for the MCAT, generally it's going to be a carbon. Where it's just
Hmm.
something with 4 different things attached to it. That's a chiral center.
Yeah.
Right,
Like
and
amino acids.
like an amino acid, like that's central carbon for most amino acids, most,
Except
except glycine.
glycine.
It's going to have 4 different things attached to it. So that's why it's chiral. And the reason these things are special is because if you have 4 different things around it, depending on how they're oriented around that central carbon, you could have two molecules that are not the exact same, that you can't just put on top of one another and they're identical. We say they're not superimposable. So in that
Mhm.
case, that means they're two different things if they're not superimposable. Therefore, that's why we distinguish. That's why it's important to understand what a chiral center is. So
Yeah.
talking about chiral centers leads us to talk about things like R and S, how to determine what's R and what's S. Things like enantiomers versus diastereomers, right? Are they exactly opposite molecules, or is they're kind of different but not exactly opposite? Also things like optical activity. Optical activity is this idea, like if you shine a plain polarized light, that's like just a light in one dimension. If there's one plane, does it rotate? Does it not rotate? These are the ideas we want to become familiar with in terms of stereochemistry. Because
Mhm.
like this is a very common kind of question when it comes to organic chemistry. Like, oh, what orientation is this? Or after the reaction, what does the orientation become? Or, hey, after the reaction, is there going to be optical activity? Is plain polarized light going to be shifted? These are the kinds of questions they can ask us when it comes to stereochem on the MCAT.
Yeah, and I feel like it's important, especially with stereochem, because it's obviously describing three-dimensional structures. Some
Mhm.
students still have like their little OChem
Oh, the
molecule kits
Ochem
from
kit.
undergrad.
Actually,
If you have those, wipe the dust off, play around with them. You can prove to yourself, and of course, Mike, you've got it.
I
Build
was
us
like,
a
wait a minute.
molecule,
I think
Mike.
I
They're
remember building these while I
they're
was like
fun.
studying. Like, yeah, these
Mhm.
are great. So helpful to visualize.
They're helpful. I feel
Mhm.
like just finding ways to help apply this to your actual real world situation is so nice. Like, for example, an enantiomer, right? These are um two molecules that have the same atoms and almost the same arrangement in space, but they're actually a mirror image of each other, right?
Mhm.
So the most common example is your left and right hands.
Right.
Like your left and right hands are pretty much the same, right? Same bone structure, same
Mhm.
size generally, like
Mhm.
they look the same, and yet you can't put one on top of the other and make one
Exactly.
hand, right? Like
Non-superimposable.
they're opposites. They're
Hmm.
mirror images of each other. That's what an enantiomer is. These are not
Hmm.
the same hand. They're
Hmm.
left and right. So like imagine a molecule in three dimensions as Mike builds a model, right? Like you could
I
flip
was just
that
playing for them. Yeah.
configuration. You can't just rotate the molecule, just like you can't rotate your hand to make it the same. So
Mhm.
whenever you're learning things like this, they can seem abstract until you make them tangible. The thing
Mhm.
is, these are describing things in three dimensions. If you try and imagine them in two dimensions in your mind, it's not going to make sense. So make
Mhm.
sure as you're interacting with this, put them in three dimensions in some way. Either apply it to things like your hands or mess around with the molecule kit.
Yeah.
Have some fun
Or
with it.
there's also a
Um,
lot of online things. Like if you're like,
yeah.
oh, I don't have a molecule kit,
Mhm.
what do I do? If you look up like online molecule kit, you can build them and you can visualize them yourself. I think
Yes.
any way that we can try, because maybe somebody's like, I don't have a molecule kit that can be kind of expensive. Totally, the internet's your friend, right? There are things
Oh
on there
yeah.
where you can help you visualize and that are totally, totally free. And so any
Yeah.
way that you can get it out of the conceptual and into like the
Mhm.
visual, I think is any like we talk about that a lot in physics when we talked about physics, to not
Yeah.
just like think about it conceptually, like no, apply it, like drop a pen, see what happens, roll a ball, see
Yeah.
what happens. Applying in this way is super, super critical. I mean, everything that we're going to talk about, this is going to apply to, which actually leads us
Yeah.
well into kind of the next high yield topic when it comes to organic chemistry, which is the idea of nucleophiles and electrophiles. Anyone who's taken any organic chemistry has heard these terms before. But to kind of like a high yield idea of a nucleophile versus electrophile is a nucleophile is anything that can donate its electrons or really attack with its electrons, right? And not going to get into nuance of like what makes a good nucleophile, what doesn't make a good nucleophile, but a nucleophile is just anything that has electrons and that can attack.
Mm.
Sure, there are some nucleophiles that are better than others, but if it has a lone pair, it can be a nucleophile. Now,
Yeah.
when I'm talking about donating or attacking with electrons, well, the thing that gets attacked is what we call the electrophile. Now, electrophile, if electrons are negative and they're attacking something, the electrophile then probably has to have what trait about it?
Probably gonna be positive, right?
Positive in
Or
some
partial
way.
positive at
Or
least.
partially positive, at least partially positive, right? Because if they're going to be accepting these very negative electrons, well, if they were negative themselves, that wouldn't coincide. So
Yeah.
electrophiles are the ones that get attacked, and they have generally the trait of being either partially positive or formally positive. And so a lot of the times what you need to know for the MCAT, don't memorize a whole bunch of nucleophiles, don't memorize a whole bunch of electrophiles. Just figure out, okay, what's got the electrons? What's partially positive? Though that's probably who's attacking who. The thing with electrons is probably attacking the thing that's probably partially positive. That's what you need to know about about the traits of nucleophiles and electrophiles.
Yeah. And I feel like, again, when we think about these things, it sounds great when you just see a definition, but see what you can do to help this really solidify in your memory. Like, to me, nucleophile, phile is like love, right? Nucleo is the nucleus, which is positively charged, right? So nucleophile is like nucleus loving, right? If you love a positively charged nucleus, you're probably negatively charged, or at least a partial negative, or you have a lone pair, you have electrons to donate, right? Electrophile, that's going to be something that is probably positive or partially positive, just like Mike just explained, right? You love phile, right? Electrons. So something that is positively charged, or at least partially positively charged, is going to love something that's negative, right? And these nucleophiles and electrophiles are pretty critical. Like, I think this is a really, really key point if you want to understand OChem reactions as a whole. There are so many different types of nucleophiles and different types of electrophiles, and there's different ways that they can interact. We could talk about SN1, SN2, we could talk about E1, E2, we could talk about a whole lot of different stuff. But essentially, we're talking about something that wants something positive and something that wants something negative. And the interactions that they can have form the basis of a lot of the OChem reactions that we have. And it's important to keep that in mind. There's a lot that we could get into here, but again, we're trying to stay as topical as we can, giving you directions on how we can learn this in more detail, right? So nucleophiles, electrophiles, really, really key.
And I think this also comes to the idea of like the mechanisms, right? Because a lot of people like tackle organic chemistry in this way where they're like, organic chemistry, I'll do it like I did in undergrad, where let me try to memorize all these mechanisms, the Michael addition, like all these things, right? No, stop. We're gonna full stop you there, right? As long as you understand what we just said, like really internalize it, all of the reactions that you've memorized is really just applications. Like most of them are just applications of a nucleophile attacking electrophile. Maybe it's multiple nucleophiles, nucleophilic steps, but they're all just nucleophile attack electrophile. Aldol condensation is a nucleophile attacking an electrophile. People have probably heard that one if they started studying. It's just an application of it. A Michael addition is a nucleophile attacking electrophile. It's just a specific example of it. And a lot of the times, the reason we don't want to get stuck in just memorizing a whole bunch of mechanisms is because all the time, you will see in passages mechanisms you've never seen before. You will see a reaction you've never seen before. And that's when people's hearts stop, in an Orgo passage. They're like, oh my goodness, I haven't seen this mechanism before. This doesn't fit my clean picture of all the things I've memorized. But that's why we don't want you to rely on memorizing here. We want you to understand, oh, hey, there's probably a nucleophile attacking some electrophile. What's the thing with the electrons that's going to like something positive, a nucleophile, right? What's the thing that has a partial positive charge? That's going to be my electrophile. Those are the kinds of things that they're going to expect. Not that you've memorized this really niche nucleophilic mechanism here. And so that's why, like, we're not going to get into the nitty-gritty, but you shouldn't want us to. Right, that's the thing. Like we can, but we won't, because again, that will be kind of counterintuitive as to how to actually succeed on Orgo on this exam.
Yeah, it's all about finding the patterns, right? And I think if you can understand functional groups, you can understand most of OChem, right? And that actually, functional groups are, I would think I think that's the highest yield thing within OChem, higher than naming, higher than, like specific reaction types, higher than analytic techniques. If you understand the basic characteristics of our key functional groups, you're pretty much good. Like, for example, we've got a bunch of carbonyl variants, right? We could talk about carboxylic acids. We could talk about amides. We could talk about, all anhydrides, all of these things. They are all related, right? They all, you can convert between the two based on actually nucleophile electrophile chemistry. The carbonyl carbon is an electrophile, right? That carbon has that partial positive charge. It can be attacked, right? And you can convert between different carboxylic acid derivatives through this nucleophilic substitution, right? It's very, very interesting. Like when we talk about different types of carbonyls, that is, of course, very important to keep in mind. Carboxylic acid derivatives, we could talk about amines. We could also talk about alkanes and alkenes and alkynes, right? There are so many different types of functional groups, but just understanding, if I see, let's say an alkane, just carbons and hydrogens, maybe there's 5 carbons and it's pentane, whatever. Understanding that basic chemistry, this is pretty nonpolar, but wait, there's an OH group on it. Okay, this is an alcohol, right? I know that OH group has polar properties, right? I know that we could talk about hydrogen bonding. We could talk about, being deprotonated and having these different properties. Like, you just need to know what is possible for each functional group. And then you could look at any molecule that the AMC presents to you, and all you're asked to do, it's not to have this molecule memorized and having, all of the possible reactions it can go through stored in your head somewhere. It's simply, let me look. I see this, and this functional group. What could I do? Maybe you're given a reactant and a product. Okay, I see this, and this functional group. And then when I move here, I only see the first 2. What now? What kind of reaction do I know that can eliminate that functional group, right? Keep an eye on your functional groups and you're pretty much good. You have so many hints as to what kind of reactions could happen, right? So that, I would say, is the most important thing for you to spend your time on more than anything else, right? What are the different functional groups? What kind of chemistry do we see associated with these functional groups, and why?
And
Maybe the why is the most important
is the
part.
big part, the why behind them, right? And I think, and if you're hearing this and you're like, oh, I don't know how to do that, we actually do an FTA, like a free trial session where we talk about mastering science passages, and the passage that we do applies these things. It's a passage where there's a whole bunch of molecules you've never seen before, but as long as you just focus on the functional groups and the traits that are there, the questions are actually not that bad, are really, really
Yeah.
straightforward. But a lot of times we're just so distracted by it. It's like, oh my gosh, this whole thing, I've never seen it before. No,
Scary.
focus on what you recognize. Focus on these functional groups that you understand. And this is a big point, and I'm kind of jumping again because I wanted to talk about this later, but I want to mention it now. You always know more than you think, right?
Oh,
A lot of the times we see molecules we've never seen before. You're like, oh, I haven't studied hard enough. I don't know the thing. No. You 90% of the time, when it comes to orgo, at least I can say this for certain after seeing it
Yeah.
so many times, students usually have enough, but we overthink it. We always think like, like I did something I don't know. No, you do know enough. You just need to apply it. Just
Yeah.
think that believe that you know enough, and honestly, the orgo becomes a lot more straightforward because it's not like, oh, I don't know this really niche esterification or this really niche hydrolysis situation. No,
Yeah.
focus on what you do know. And so
Especially because you have 4 options. Maybe
right.
just competence is not going to be enough to get you an A in OChem in undergrad, because it's a very different task that we're asking you to do when we give you an MCAT question, right? You don't need to have every ounce of understanding that you needed in undergrad. This is such a different exam. It's such a different way that this information is tested. You just have to figure out the best answer out of 4. That's it, right? So know what you're being asked to do. And I feel like that's why you do know more than you think you do. You
Right.
don't need the same depth of understanding. Although, of course, it helps.
It
I
would
hope you
help, but
guys
like
all study it and understand it. But like, I don't want you spending a month and a half trying to master OChem to be able to get an A in undergrad, because that's not what we're asking you to do.
it really isn't. It really isn't. And I think we've talked about a few of like the whys of the reaction, the different functional groups. And I think there's kind of some big reaction classes that students should be familiar with, will be tested on this exam. We're not going to get into the really nitty gritty about them, but kind of big picture. So for
Name them, yeah.
example, right, SN1 and SN2. That is definitely, in terms of like reaction classes, something you should be familiar with. When
Yeah.
will SN1 be favored? When will SN2 be favored, right? These are nucleophilic substitution reactions. So things like, oh, how many steps is each one? Is one's one step, one is 2 steps. Yeah, what conditions, like I said before, what kind of nucleophiles does it like? What kind of electrophiles does it like? These sorts of traits you want to be familiar with because they will ask you these sorts of questions, like which one will be preferred, or what kind of an electrophile would be favorable, or what change can we make to prefer one over the other. In these ways, we should be familiar with SN1 and SN2 and what they are. They can be
Yeah.
applied in so many different ways. Don't try to memorize every single way it can be applied, as long as you understand the big picture.
Yeah. And as long as you know how to tell the difference between your reactants and your products, right? Look at your reactants. What kind of qualities does it have? How many, if it's carbon in the middle, which keep in mind SN1 and SN2, you're essentially just substituting out one functional group for another. If you visualize it, that's kind of what you're doing. How many substituents are on the initial carbon? That's a huge clue, SN1, SN2. Also, what's happening with the stereochemistry that we mentioned earlier? That's a huge hint, SN1, SN2. Like, if you can apply the things that we've already talked about to this reaction and every other, you don't need to have it all memorized, right? You can quickly figure out, oh, this must be SN2 because I see functional groups being exchanged and because I see that stereochemistry was inverted. Again, you'll want to study SN2. You want to know why that's the case, but that's an example, right? You're applying these same concepts that we've already talked about to reactions so that you can make your way through whatever reaction they throw at you on test day, that's the goal.
Right. And I think, so while SN1, SN2 is like probably in terms of like orgo reactions, one of the big ones, the other big ones in orgo is oxidation reduction, like redox reactions in organic chemistry. Because redox is definitely in Gen Chem, 100%. You should know what redox is in Gen Chem. And Biochem, right? A lot in Biochem when we talk about metabolism, especially. We dove all into that.
I know, it's actually my favorite topic.
Yeah, it was super cool. But in organic chemistry, oxidation reductions also come. Notice how high yield redox reactions are. Because in organic chemistry, we want to be thinking redox reactions in terms of how it changes one functional group to a different functional group. There's kind of three functional groups we normally talk about when it comes to redox chemistry. So that's going to be your alcohols, to your carbonyls, to your carboxylic acids. And so these are the ones like switching between them, right? Going from an alcohol to a carbonyl. There's now more bonds to oxygen, so now it's oxidation. Oh, a carbonyl to carboxylic acid, more bonds to oxygen, so still further oxidation. And therefore, in the other direction, carbonyl to alcohol, carboxylic acid to carbonyl, those are reductions. And so when you see these in a passage, so when you see, hey, an alcohol just turned into a carbonyl, probably a good hint that there's some sort of a redox reaction going on. And here, this is where we also kind of want to introduce the idea of reagents as well. Because there's certain reagents to know that like, oh, this reagent is an oxidizing agent. This reagent is a reducing agent. So when you see those reagents in your reaction, like maybe you're like, oh my gosh, there's these big structures and there's some functional groups, what's going on? But then you see something like NABH4 in your reagents, you're like, oh, NABH4 for context is a reducing agent, a very, it's not the strongest reducing agent, but it is a reducing agent. Probably some sort of a reduction is happening. So maybe you can know to look for that. So redox reactions, organic chemistry, along with SN1, SN2, kind of those in my mind are like two of the biggest ones to kind of be familiar with in orgo.
Yeah. And we've talked about oxidation reduction before. We talked about them like individually, and then we applied them to especially the electron transport chain, which is one of my favorite things. That and electrochemistry. Like, there's so many applications. Redox is very, very important. But again, super crash course. It's all about transfer of electrons, right? Leo goes GER or oil rig, but Mike and I, we're team Leo goes GER for sure. And the whole idea is, are you gaining bonds to something super electronegative, or are you losing bonds to something electronegative? What's going on, right? Redox reactions are critical. And again, you could study redox reactions and you're really studying for OChem, Gen Chem, and Biochem, right? Like there are certain topics that really do form those connections between subjects, and those are the ones that are really worth highlighting. So like, if you ever see that, definitely check it out. Little plug for a free resource of ours, the textbook. We've got a bunch of content bridges in the textbook. Again, if you're going to try and study OChem, please don't buy an OChem textbook online. Make sure it's MCAT specific, because a lot of OChem, as we've talked about, is taught in a very different way if it's undergraduate level versus MCAT level. And also a ton of what you're going to see as far as OChem passages and questions are going to be applying OChem to other subjects. Okay, so just keep that in mind. Redox is one of those things that can be asked about in many different sections. And when we talk about redox in our OChem textbook, we bring all those other connections in. Again, we've got a bunch of free textbooks and they're all amazing. So check them out if you want to start doing content review. But make sure, if you are going to study OChem after we've talked and you're like, cool, I want to go learn redox, I want to go learn SN1, SN2, or E1, E2, which is a related reaction, not quite as high yield as SN1, SN2, but it's one that you want to know too, right? Or you want to study the carboxylic acid derivatives or go start looking at aldehydes and ketones. Like if you're feeling jazzed up and ready, we just advise use an MCAT specific resource so you don't feel like you're drowning in OChem.
Right,
Keep in
right.
mind, 10 to 12 questions out of 230. It's not the end all be all. And even now, you could probably get at least 3 or 4 or 5 of those questions right just with the stuff you already have in your brain, right? So just if you're going to study, that's some basic advice, right?
Sure, absolutely, absolutely. Kind of really echoing this idea of don't try to study for this like it's an undergrad. Please do not study for this for the MCAT. Be very intentional.
Intentional.
Yeah, right. As soon as I saw in your eye, saw the intention in
I'm
your eye, and I
like,
was like,
uh-huh.
I know where you're going, Molly. Yeah,
Yeah.
100%. And so, knowing kind of like yeah, like kind of recapping SN1, SN2, know those redox reactions. E1, E2 happen
Less.
like really like
Yeah.
the only one I can think of like dehydration reaction probably should know that one.
Hmm.
That's like the main one.
Hmm.
And then also carbonyl chemistry. That functional group
Yeah.
carbonyl coming back. Carbonyls are just so you see they're so prolific, right? In a lot of what we
Hmm.
see. A lot of biological molecules like hydrolysis, esterification for like your peptides, your fats. Carbonyl chemistry is really, really present there.
Yeah.
So be familiar with carbonyl chemistry, but again, don't try to memorize all these different situations. Just be really familiar with the idea that carbonyls
Basics.
really good electrophiles. So so are like, and again, of course, there are better electrophiles, but they're a pretty common electrophile, so they're probably being attacked by something.
I
So that's like the basis of it in my eyes.
I
Yeah.
feel like it's important to mention that a lot of the applications that you're going to see for OChem are OChem in the body, right?
Hmm.
Not exclusively. You could see like completely
Like a lab technique or
in a
something like
lab.
that.
Yeah,
Yeah.
that's very possible, but often you're going to see reagents and things like that or biochemical I shouldn't say biochemical, organic chemistry
Hmm.
setups that have things like that, right? Like a biomolecule that has a carbonyl. It may not be the best electrophile ever, but keep in mind our body does not have extreme molecules very often. Like we don't
Hmm.
have incredibly strong acids in the majority of our body, right? Stomach acid's pretty strong, but like we're going to make sure that we've got buffers. We don't want
Right.
super acidic, we don't want super basic because it'll hurt our cells. Like
Hmm.
in order to sustain life, we pretty much favor the weaker side of organic chemistry, reagents and
Sure.
molecules.
Hmm.
So it's not that you can't get really strong acids or bases or really strong reducing agents or really strong oxidizing agents in a passage. You can, but like
In the body.
biology
Hmm.
favors that middle ground where we're not too strong in either direction.
Hmm.
And it's valuable to keep in mind.
Hmm.
Not that you can't see that in OChem, you will, but especially when OChem connects to biology and biochemistry and general chemistry, oftentimes you're going to see like the more middle ground that's
Sure,
biologically
sure.
relevant.
In like in an typical case, but you can imagine like, and I can just think of like one example where it's like, oh, when we have the extreme, it's usually not a good thing. I'm thinking of like
Yeah.
radicals, for example. Like when you have like
Yeah.
radicals, those are pretty
Mhm.
strong oxidizing agents, but it's not a good thing to have those things. That's where it's
Yeah.
like, yeah, in the body, if they like for regular reactions, you'll have those many things. When you have these strong things, it's usually something's going on. Like, oh, this is actually a problem because it's so strong.
Yeah.
Um,
That's why you have your berries and your
that's why I
smoothies and
got
your
your berries,
antioxidants.
yeah, antioxidant, all those things. But yeah, that's all a lot of fun in the body. And so we've gone over kind of like functional groups, need to know those. We've gone over stereochem, you need to know it, and like the big reaction classes, you need to know those.
Mhm.
Another one that again, even I at first didn't even think of this as orgo very much, but this is
Mhm.
classified under orgo by the AEMC, is spectroscopy, and a lot of your analytical techniques is under organic chemistry. So some of your questions that are dedicated to organic chemistry will be spectroscopy questions. So these are going to be things like IR, like infrared spectroscopy, HNMR usually. I don't think I've even seen
CMR.
non-HNMR. Yeah, like
I
so I
don't think
usually
so.
yeah, like they're usually just hydrogen NMR, mass spec, and even mass spec is not the highest yield of all of them. These sorts of analytical techniques. I mean, I don't even think mass spec is technically a spectroscopy, is it?
It's a combination.
It's a
It's a
combination of
weird,
it
it's a
uses
weird
mass and then
combo
measures it.
of
Yeah. we'll
Yeah,
put it under
the
there, but it's not
electron
all
beams
about.
and the acceleration and then
Yeah.
spectroscopy. It's a
So let's group it there. I don't think it fits there, but these analytical techniques also fall under organic chemistry. So
yeah.
we're gonna go over them quickly here. We're not gonna go into all the numbers. This is where, and I say this with a very, very heavy heart as somebody who has an awful memory, this is where some memorization is a little bit required in my eyes.
Yeah.
With some
And
numbers.
it,
Yeah.
but it's not too bad,
It's
right?
not too
And if
bad.
you Google a lot of this stuff, you're going to get way more depth than you need. So
Mhm.
to kind of just walk us through the very, 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 very basics. Okay, when we talk about IR spectroscopy, it's all about identifying functional groups.
Mhm.
And this, I think most of us have seen in OChem lab or Gen Chem lab or something in college. Like it's a pretty cheap technique. A lot of
Mhm.
us have done it before, even if you don't remember. You're
Right.
going to basically load a sample in here and you're going to get this spit out image with all of these peaks. Okay.
Mhm.
And you're going to see differences if you have like an or an OH group, like an
Mhm.
alcohol group. You'll
Mhm.
see a big stretch at like 33, 3400. It's going
Sure.
to be really broad, really wide. It's going to be really obvious. There's another stretch for carbonyls. If you have like a C double bonded to an O, that'll be a
Mhm.
different area. If you have a nitrogen attached to a hydrogen, that will also show up. Like it's it's a pretty complicated pattern. You've
Mhm.
probably seen one before, even if
Mhm.
you don't remember. But it's all about identifying functional groups. There are a couple functional groups that are useful to know the actual values for, but again, you're going to have process of elimination if you need it, right? When we talk about NMR, this is all about the environment around hydrogens. This
Mhm.
one I think gets students really confused because you have shielding, right? We're talking about like how essentially how complicated is the environment around hydrogens? Like
Intriguing.
I don't want to get too into depth. Like if
Sure.
we're attached to a very hybridized carbon, like if
Mhm.
this is a carbon attached to a double
Right.
or a hydrogen attached to a double bonded carbon or a triple bonded carbon, it's going to show up in different areas. If
Mhm.
this hydrogen is attached to something really electronegative, it'll show up in a different area. If there are three hydrogens that are all chemically equivalent, you're going to see a different pattern.
Like a higher peak or something. Yeah, yeah.
Right. It's a complicated system. I wouldn't say it's the number one most important to know, but it's worth it, right? It's
Mhm.
all about the environment that hydrogens are in, if it's
Mhm.
HNMR. UV vis spectroscopy, this is all about visible light, right? Or
Mhm.
ultraviolet light.
Mhm.
This is a lot of pigments, right? So
Mhm.
pigments, things that provide color, things like that, are really big molecules that tend to have a lot of double bonds and they
Mhm.
absorb light in the visible or in the UV spectrum and they actually give it back.
Right.
So we can use, rather than IR infrared spectroscopy, we can use ultraviolet or visible light in order to create this. It basically it's just for really conjugated double bond systems or aromaticity, right?
Mhm.
So just a different type of molecule that you would use that for.
Mhm.
And then there's chromatography. And there's actually so much we can get into with chromatography. I love talking about chromatography. We could do ion exchange. We could do thin layer. We could talk about HPLC. We could talk about just column chromatography. But the
Or
whole idea with
affinity. That's my
chromatography,
favorite one. Affinity
what
chromatography is mine. Oh,
is
affinity
which one?
chromatography. Oh,
Oh,
affinity
affinity
chromat.
chromatography.
Yeah, yeah,
Yeah,
yeah.
me too.
Affinity. That's
Yeah.
my favorite because that's the very much like we don't care about all this extra stuff. It's just like target that one thing.
It's literally so specific.
Yeah.
But chromatography as a whole is basically let me separate things based on a particular property, either
Hmm.
because you're charged in a way that I'm desiring, or you're polar or nonpolar, or you have a particular functional group or a
Or
particular structure.
tag. Hmm.
Right. Like there's something specific that, or some specific criteria that we're going to use to separate stuff. Okay.
Hmm.
There's so many different types of chromatography, but they all separate based on something slightly different. And that's the
Hmm.
key. You might be asked to predict the order of separation or, where is this going to end up? Things like that. There's a lot of different types of chromatography, but I feel like you see it, it's not uncommon to see. I feel like it's
Yeah.
worth its time to go and check it out.
Chromatography, definitely.
Yeah.
Definitely in a lot of those like lab technique kind of passages where you have some sort of like purification where you're trying to like isolate something, you have a mixture, or maybe after
Yeah.
a reaction, you have a whole bunch of things, so now you're trying to like separate after the reaction. So I mean,
Yeah.
something we didn't talk about, like liquid extraction, that's another method to
Mhm.
separate.
Yeah.
That's where a lot of times the context that you're going to see them, where a lot of times
Yeah.
they're going to bring up the name of the chromatography or extraction that they did,
Hmm.
and then the questions, again, pay attention to when they say up, oh, they use this chromatography technique, because I can swear to you, there will be a question that says, oh,
Yeah.
what trait, what was it using? Or something, and maybe
Hmm.
even not as heavy-handed, like, oh, which one, in at which volume did it come out? Or did it come out first? Did it come out last?
Hmm.
Like our
Yes.
product. These are the sorts
Yeah.
of questions that they're going to ask. So when you have these sorts of things in a passage, pay attention to when they come up.
Highlight them.
Highlight them. That's our buzzword. That's our like, oh,
Yeah.
you see that? Again, a lot of times I've seen students struggle because they highlight the word chromatography.
Yeah.
They didn't focus on what
Hmm.
kind of chromatography they had. So they were like, oh my gosh, how should I think? No, focus on the chromatography, what kind of chromatography, that because that tells you so much about the
Yeah.
trait that they're targeting, and which that's the part they'll ask about.
Yeah. And I also feel like it's worth mentioning that chromatography is really the only one that of the ones we just mentioned that you will also see in biochem.
Hmm.
Right? Like I don't think you're not going to see NMR in biochem. You're
Oh,
not going to
really?
see a ton of IR or UV vis spectroscopy. Like those are pretty localized within ChemPhys. Chromatography though, that's fair
Hmm.
game in either section,
Right?
right? It's probably more common in chemistry and physics, but that one I've seen in both. Okay,
Hmm.
so that's another reason why it's worth knowing, especially
Right,
when we
right.
talk about like ion chromatography and things like that. Like it's worth being familiar with, not just for ChemPhys, but also for biochem.
Absolutely.
So this material, again, the connections are really key.
Hmm.
And I feel like that's when we talk about analytic and basic separation techniques. We've talked about functional groups. We've talked about very important core reactions to be familiar with. We've talked about stereochemistry and carboxylic acids and things like that. I do you feel like we're missing anything? I feel like those are the most important things
Yeah.
to keep in mind.
Right, right. When you're studying orgo, not to go like really, really in
Hmm.
depth on the mechanisms, but rather understand the fundamentals of what we just spoke about. And I can't think of a question in recent memory that you wouldn't be able to do as long as you
I
understand those
agree.
core things.
I agree.
And I think so while those are kind of those high yield topics to kind of be focusing on to make sure you understand well, right? We also want to talk about how OChem shows up in a passage. We've been kind of like hinting at some examples as we've been
Hmm.
discussing. But when you see OChem in a passage, a lot of times you can see them, in my eyes, there's kind of like one of two ways that it can kind of show up. The first way is like on with a biochem emphasis, right? Where it's like
Hmm.
there was like an enzyme and then there was like, oh, a reaction with the enzyme. And they might kind of focus not only on the product, the enzymes catalyzed like substrate to product, what changed in terms of the actual reagents, or maybe they might talk about the actual enzyme itself, how at the actual active site, was there a nucleophilic attack? Was it a deprotonation, a protonation? They might give you
Hmm.
that case in like a kind of a biochemical context. Whereas
Yeah.
the other kind of, and I think that's more common. I see those kind of more often when it comes to how orgo shows up in a passage. I think the other way it's going to show up is really just like the straight kind of like lab technique where they're like, hey, there were some chemists that want to develop a new drug. They did this. Here's a whole bunch of steps to develop the new drug. And they ask you that sort of thing. Where
Hmm.
both of those will be testing orgo techniques, but kind of the context that you'll see them is going to be usually one of those two ways in my eyes. I think when I think of orgo, that's usually the two ways that I think it shows up.
Yeah, I feel like given the fact that Orgo questions
Mhm.
are, it's just like 10 to 12 of them out of
Mhm.
230, there are sometimes that you get passages that are all OChem, right? And
Mhm.
that's when you see all the lab techniques, or maybe you just see like a giant chemical reaction. It goes
Mhm.
step by step, and you might get a
Right.
paragraph that's walking through all the junk, right? All the
Mhm.
steps, all the different intermediates, and then you get the reaction scheme. Like that is definitely possible. That's like a pure OChem passage. You can get questions about like how can we monitor this reaction using spectroscopy, or how can we identify if a particular polar reactant or product was formed using chromatography, something like that. Like there are pure OChem passages,
Mhm.
and then there are also times where you'll see OChem integrated into something else, like you said, a biochem passage, and then there's an OChem twist in there. I
Mhm.
also think a large portion of the questions you see about OChem are actually not, it's not, there's no anchor of OChem to the passage directly. Like we might not have directly stated a lab technique, or we directly hinted that we were going to ask you about something specific. Sometimes you see a passage that pretty much feels like all biochem, and yet you get a question about OChem. Or a passage that feels very general chemistry, and yet here's an OChem question, right? Like OChem it's very easy to sprinkle in when the passage is focused on something else, because it's basically asking for a deeper understanding of chemical reactions, right? Even if something's presented on a pretty surface level in the passage, they could give you some new info, or they could ask you to reason through why something reacts that way, even if they just give you the structure of a molecule. That's pretty ambiguous, right? They just give you what the molecule looks like. They then could ask you about its properties based on its functional groups. Guess what? That's OChem, right? So like one of the things that I want to hit on here is like, you might not even realize that this is an OChem question when you take the question. Sometimes it doesn't feel obvious. It doesn't feel like what we expect OChem to be, which is always why whenever we are talking about studying material for the MCAT, you have to go with data in hand when you go and decide what you want to spend time on. Don't just say, oh, OChem scares me, I'm going to go spend a bunch of time on it. Look at your practice questions. Look at your most recent full length. How am I doing on OChem compared to other sections? I think most students are surprised, like, oh my God, I got a 70% in my OChem questions. I figured it would be like a 10 or 20%, right? They use their analytics to review and they're like, this is an OChem question? Yeah, it is, right? We don't think about it all the time. Sometimes you're going to be surprised that, you didn't realize that this was organic chemistry. So that also can make up a good chunk of your OChem questions. Stuff that you don't even realize is OChem. And to me,
OChem.
as someone who is scared of OChem, that is the biggest gift
Right.
ever. Like, I
You're
love
like,
that.
I love that I can be kind of surprised with the OChem questions. And I also think that you hear this a lot, and I kind of wanted to see, like, I hear a lot of times the opposite, where people are like, oh my gosh, my exam was all OChem. Like, oh,
Yes.
everybody, like, my exam was super OChem heavy. Like, oh, don't believe them when they say 15%. So here's kind of what we know about what's true.
Mhm.
We know about the percentage of the questions that are OChem. That's kind of like they owe you that. That's the rule. It is going to be 10 to 15%. But they can have passages that are very OChem. So to your point, Molly, it was like you can have passages that are not OChem at all, and then have questions that are OChem related. You could
Mhm.
also go on the flip side where you can have passages that are all OChem, like that look all OChem, but then all the questions like aren't really OChem related at all. Where a
Yeah.
lot of the times people are like, oh my gosh, study your OChem because my passage is all low yield content. No, probably the passages had some stuff you didn't know, but then the questions were not really OChem, right? This is
Yeah.
the idea where a lot of people are like, oh, is the exam really changing that much? I heard what this person said. This is a problem with taking like anecdotal evidence, like with taking like
Yeah.
what somebody said, because our memory is a lot of time very stained by like our emotions, right? Like, oh my
Yeah.
gosh, like it was all OChem when in reality, like there's maybe a passage or two on it, and then not even all the
Right.
questions were all about it. So that's one thing I want to say because some people are like will be surprised by the kinds of stuff that are OChem, but some people will maybe also be shocked by the stuff that kind of isn't OChem. Like if it's just because it's a question
Mhm.
associated with an OChem passage, doesn't mean it's an OChem question. Like really.
Yes,
Um,
absolutely.
and I think there's like a big strategy we kind of have been kind of hinting at and really saying, and I'd rather really iterate again. When you see OChem in a passage, you see a whole bunch of reactions. It's okay to not know exactly what the reaction is. It's okay when you
Mhm.
see one functional group go like you see a molecule and they give you like a reaction scheme and you see another molecule and you see it's changed, right? You see, oh, it was different. A lot of students just sit there and like stare at it. They're like, I need to figure out
Yep.
what happened here. And like I'm gonna be honest, when I read OChem passages, even to this day, I have no idea what happened. I'm like, I see one molecule go to another. I'm like, I see what's
Cool.
different. I see what's changed. Oh,
Mm.
this alcohol became this other group. Okay, cool. But I'm like, all right, cool. Let me move on. Or maybe I
Yeah.
can guess at it. Like, oh, maybe if it was two things that became one thing, maybe I can be like, oh, probably some nucleophilic attack happened. But like a lot of
Mhm.
the times we try to like we stress out because we're like, oh my gosh, I didn't memorize this specific reaction. Where a lot of times you
You know,
didn't need to. You really didn't need
yeah.
to. And if they ask about it, they'll give you hints because there's only four answer options. So
Yeah.
that like, you can actually like assess each answer option. Oh, is that happening? Oh, no, that's not happening. Oh, is that? Well, I guess the nucleophilic attack's happening, so sure. Oh, it's not dehydration. No. And so you can just
Yeah.
eliminate your way there. So just trust when you're in the passage, if you see something you don't and you don't know exactly the reaction, that's okay. Give yourself some
Yeah.
grace. You're probably not meant to.
Yeah. I pretty much do one of two things when I see a giant reaction, right? And it depends on the passage. So if there is and we mentioned this last episode when we were talking about types of ChemPhys passages you might see. If you see a really dense paragraph that's giving you like in step 1 of the reaction, this reacts with this and forms this, and it's this kind of reaction, and this reagent was used in step 2, blah, 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 blah. And I see that there's a picture, I'm like, cool. I'm going to read through the steps and I'm just going to like kind of glance down and watch the pathway. If I get that big chunk of context, I'm going to look at that figure while I'm reading to help me integrate things. And basically, I don't have to draw anything. If I get a big reaction scheme with no walkthrough in the passage, I'm going to give myself like 10, 15 seconds of like, okay, what does anything jump out at me? Like, do I see anything clearly? And if I don't, I'm like, awesome, let's keep going. Because the thing is, and again, we kind of went through some scenarios last episode, you know, here's a hypothetical passage layout. Here's the type of question. Where do you think that question's going to come from? It's so obvious when a question is asking you about the reaction because it's going to ask you about step 1 and step 1 is in the reaction. Or like it'll ask you about, you know, reactant 4 and it's like, there it is, right? Like if it's asking about the properties of a particular intermediate, you're going to need to look at the structure. If it's asking you about what enzyme could carry that reaction out, look at the products and the reactants, right? Like what type of reaction is it? If they're asking you something specific, it's so easy to direct your attention there. That I think, especially for students that really get overwhelmed or really scared of OChem, again, if they walk you through it, okay, that's pretty important. Like they're dedicating a giant paragraph and giving you a figure. They may ask you a more in-depth question, but if they just throw it at you, do not spend 2 minutes trying to brainstorm and like putting like step 1, okay, I think this is in a redox reaction and reagents included may include this or that. You're gonna know if a question is asking you about the reaction. So give yourself a couple seconds. Do I notice any functional groups? Do I see anything changing? Does anything jump out at me? Maybe you look at the starting material all the way at the beginning and the very, very end material, and you're like, oh, okay, I see that I've lost an alcohol, I've created a double bond, and I've done one other thing. Cool. Cool. Right. And then move on. Don't get too caught. And I feel like don't get too caught even applies to the content. Don't get too caught in OChem. Right.
And I think also on the other flip side, I've seen students who get like so caught in the passage and the reaction, but also on the opposite, who they see a reaction and it's just like, nope, and just like skip it entirely. Or don't do that either. Please don't do that either, because like you put, Molly, like you will get questions that maybe will ask about it. You need to know what was there to begin with so that you know, oh, I need to look back on now, maybe spend a little bit longer focusing on that. But a lot of the times if we just like out of sight, out of mind it, and we just completely skip it, when they do ask a question about it, you don't know where to look. You're like, oh, where am I supposed to go? So there is kind of like, again, a Goldilocks zone where, yeah, please don't dwell on it. Like see what you can pick up quickly. See, oh yeah, that functional group's gone or we've added that. But also don't just skip it. Please don't just skip it.
Yes, absolutely. It's kind of the same with data interpretation, which we've talked about before. You don't have
There's
to
a lot of
sit there.
similarities. There's a lot of similarities. Yeah.
I mean, it's figure interpretation. We'll speak generally, but like you don't need to know literally everything because you might not get questions about literally everything, but you should have an idea of what's going on, right? On a basic level. Give yourself a couple seconds, see if you can figure it out. But I think that's a really key. If we were to just like kind of rapid fire some OChem tips, right? Like don't get lost in the weeds while studying for OChem. Don't be going through all, 200 OChem reactions that you had to learn in undergrad. Like that is too much. You're doing too much, right? Because you're not going to see all that and you're not expected to bring that knowledge into this exam, right? Like you're expected to be adaptable. So don't overinvest and instead invest in the right places, invest in the things that we've mentioned before. And that applies to passages as well. You don't want to overdo it, right? You've got time, you've got 4 answer choices to work with, and you've only got like 10 or 12 questions on your whole exam that are OChem, right? Don't overthink it. Focus on the guiding principles that we see that ultimately help us navigate situations like this. Don't get too scared, right? Look for the patterns, look for the things that you're already familiar with, and use what you know to unpack new situations. I think that's like the most key single piece of advice. Like, you know more than you think you do. don't freak out, right? Like
Mhm.
you've got it. You've got it. Just use what you know and reverse engineer it, right? You've got four options. Your job is just to figure out which of the four is correct, right? Know what you're up against and know the
Right.
depth to which you need to go in order to get the right answer.
Yeah, yeah. Also, what's going to be super helpful is that when you see a reaction in a passage, you put it wonderfully, Molly. Like if you see like they're going over this whole mechanism, you see this chunk of information, and you see the reaction there, fantastic, follow along with the reaction. But if you don't see the reaction there, use your scratch paper. Oh my
Yeah.
goodness, we talked about like kind of using your scratch paper in two episodes before this now in our general sciences, but also in our mastering chem phys episode. But a lot of the times we see these mechanisms and we get so overwhelmed because we try to keep it all in our minds. We're like, oh my gosh, I'm so confused. What's going on? Take a second. A lot of times when they don't give you a mechanism, it's not the longest passage in the world. If they go really in depth, draw it out. Write out a little alcohol, like it goes to, oh, now this is a carbonyl. Write out, hey, this thing is phosphorylating it. If they don't give you a figure, give yourself a little bit of a scratch mechanism. Again, don't go super in depth on it. Don't draw every single
Hmm.
functional group on it, but just get the general idea down so that when they ask questions, like, because they probably will ask questions on it, you already have it down. You're not super lost in the sauce, as they say. You actually anchored yourself somewhere. So please utilize your scratch paper in scenarios like that.
Hmm.
Always, and we also mentioned this before, but don't just memorize OChem or learn OChem like in a bubble, where it's just the OChem
Yeah.
bubble, where you're just like, oh, let me just study what a nucleophile and an electrophile is. Understand that when they test these things, they're going to test them in the contents a lot of the time of biochem. So when you're learning
Hmm.
these things, learn them and bring it back to biological relevance. When you learn about, like a carbonyl chemistry, think, oh wow, there's a whole bunch of carbonyls. Things like, peptide bonds have a carbonyl and a nitrogen. Oh, that carbonyl is attacked a lot of the times when it's broken. Oh, we also see that in fats. There's a carbonyls there. So those a lot of times get attacked when we cut those fats. When you're learning these mechanisms, think about biological applications to them. And because that's how they'll be tested a lot of the times, not in just this little bubble of OChem. And
Yeah.
so always connect back because not only does it help you when answering the questions, but also helps you to stick. Helps to stick when you're
Mhm.
learning about them. So it's not just so conceptual and so vague. You actually have applications for it.
Yeah.
And
And
truly, oh, sorry, go ahead.
I was just gonna say, and that's so, so key, right? Because this is not in a bubble. In fact, and this is gonna shock a lot of people. I don't think we've mentioned this officially yet.
Mm,
We said it was 15% of Chem Phys, which it is. It's also 5% of Biochem.
mm,
There's a teeny bit of OChem in Biochem, and that's where we see chromatography. That's where we see the separation techniques. But like
mhm,
you need to be ready to make those connections because not only is bio and biochem tested in chem phys, OChem, although it's literally 5%, it's like, one question, maybe two, that's in biochem as well, right?
mm,
Like there are so many connections, and that's what we need to be ready to do. You should never learn content in a vacuum, right? You never go just one subject. Let me learn all of physics and then all of gen chem and then all of biochem and then all of ochem and then all of bio. Please never do that. The connections are where the points come from, right? But
mhm,
I don't think most people know that there's a
mm,
teeny bit of OChem in biochem or OChem in biochem. And it's because of how important these biological connections are, right? So if you want to do well in the OChem portion of Chem Phys, make sure you know the connections, but also especially if you want to get those one or two questions right in biochem, make sure you're ready to do this. That's the
mhm,
that's the take home here.
mhm,
Focus on the connections more
mhm.
than just shoving all this stuff in your brain and hoping to, get those questions right.
Right. Right. And I think kind of that's like a really great like kind of like way to like wrap up OChem and kind of how we would think of
Mhm.
it because our goal is that to make OChem a little bit less scary. That was our
Mhm.
goal today is to because we find that a lot of students have kind of this misrepresentation of OChem or have this big fear of OChem. But really, I think this was a great quote. I heard it, and I don't want it to be taken out of context, but OChem's only really scary if you over prepare for it. Right? If you
Yeah.
over memorize for it, if you like try to memorize, it feels so overwhelming, it feels like such a massive beast. That's when it becomes really scary. But when you realize it's really just a lot of applications of a few fundamental principles, it doesn't actually end up being that bad. But so
Mhm.
if you're listening, if you've gone to this far, please make sure when you're studying your OChem, understand the principles, don't get lost in the details, and that's what's going to help increase your score in OChem, not memorizing what a Michael addition is. I can promise you that.
Yes, exactly.
And
Yeah.
so this is how kind of like if you're really looking to increase your score, focusing on the kind of big groups like functional groups, those main SN1, SN2, redox reactions, thinking about lab techniques, you focus on those, that's what's going to help increase your score.
Yeah. And that's true. Again, mostly true of ChemPhys, but that's true of biochem as well, right? Don't forget our lab techniques. We're going to see a lot. We'll even see new lab techniques in biochem that we have not talked about yet. Things like gel electrophoresis and SDS page and all those fun things, which kind of leads us pretty well into our next topic of discussion for next episode. We've talked a lot about chemistry and physics over the last month, right? We did MCAT
truly.
math. We talked about physics content in forces, energy, and power. And then we talked about how to master ChemPhys, and we talked about OChem. We're now moving into biochem.
Ooh, we love bio
Woohoo!
I truly, this was the one section I remember when I was studying for this. Like, this is actually I actually really, really loved because this was kind of like really along the passions. Like a lot of us going into medicine, like this, and I don't mean to be very blunt, but if biochem doesn't interest you, you're in the
You're
wrong
probably in
field.
the wrong field.
You're probably in the wrong field. Like this is
Yeah.
where the anatomy is going to be. This is where you're going to be making a lot of connections between hormones and different systems. This is the stuff that's going to be your bread and butter when you're a physician. And so we're going to
Yes.
be talking about a lot of times these passages are not our bread and butter. A lot of the times these kind of like can scare us. A lot of the times these bio passages can be really overwhelming because they bring up a
Yeah.
whole bunch of new things. So we're going to be talking about next episode how to master, how to tackle these bio passages as they present on the MCAT.
Yeah. And I'm excited about this because I think the test writers know that people love bio and they love biochem. Because if you didn't, then medicine is probably not the best,
Yeah.
right? Like,
Mhm.
unless you're trying to get into specifically some research application, it's a lot of bio and it's a lot of biochem. I think biochem passages, if you just think of the passage itself and the data they'll ask you to interpret, the types of questions, I think it has the hardest passages and the hardest questions out of any science section. Kind of by far, the most complex. Every passage, it almost feels like you're drinking from a fire hose. They
Right.
really do just spray your brain with so many things. And again, it's stuff that you're comfortable with, but objectively, these are the hardest passages in science sections on your exam. So I'm very excited for next episode, and to get into the real nitty gritty with the biochem section. So stay tuned. We hope you're as excited as we are to talk about it. And thank you. If you've gotten all this way, listening about OChem on the MCAT, we hope you found something useful. Again, if there are things in OChem or in any other subject that you specifically want us to talk about, whether it's content or strategy, let us know in the comments. Shoot us an email. Come see us in free sessions. We love to hear from you. We like to give you guys what you want and what you need. So let us know if there's something that you want or need, and we'd be happy to get it for you. Until next time, happy studying. Have a wonderful rest of your day, and we'll see you later.
See you, everybody.
Welcome to the Jack Westin MCAT podcast with your hosts, Michael Maleka
and Molly Hudash.